this work? All right, we're recording. Yay! It should be working now. So, good morning, good afternoon. Sorry. Welcome to the new term. So sorry that this has been so awkward and weird and crazy things have happened. I know if you're watching this and you were not in the Zoom meeting, you don't know anything about the crazy, but trust me, there's been crazy. So, my name's Melissa Kleiss. I've been teaching at RCC for about 8 years, but and technology issues is not brand new. And I'm actually pretty good with technology, believe it or not, but today is just one of those days. So we're today's objectives. We're going to work through chapter one. Chapter one is almost all vocabulary. So it is what it is. And the first meeting, other than the craziness of the technical difficulties, the first meeting is always pretty boring, super vocabulary heavy. Learning stats is very much learning a whole new language. So you're going to get the gist of the language, the basics of the language today. And then we'll start really doing some math. The real math happens next week. You will not need your fancy calculator today. You're going to just get a lot of really good vocabulary. When you do get your calculator, it might look something like this. And how come my screen is not shared? Is it? Or is it? Yeah, it is shared. Okay, sorry. Okay, so your calculator is going to look something like this. I have a TI-84. That's what I'm going to be using in class. I also have one that I'm going to be able to put on my screen so that you can see when I'm doing the calculator. You're going to learn to use a lot of new calculator functions. There's a whole bunch of them, and I will be really step by step showing you how to use each one. We'll also be using Excel. It is required that you use Excel and not Numbers or Google Sheets. It is free if you're a college student for as long as you're a student at RCC. So it's a pretty good deal because it's a very expensive program. There's a link in the Start Here folder that will help you get started installing it on your computer. All right. So in chapter one, we're going to talk about what statistics are and statistical thinking. We're going to talk about the process. We're going to define quantitative, qualitative data. We're going to look at discrete and continuous and look at some examples, and then something called level of measurement. We're going to just dip into section 2.1, and we're going to talk about how to put qualitative data into tables and looking at bar graphs. So that is the start of this. After tonight's meeting, you can only see my screen, not both. So you can't see the PowerPoint. That's all you should see is the PowerPoint. That's all I need you to see right now. The calculator won't come in play today. Okay. Okay. So that's all you should be able to see at the moment. Can you see me? You can see me in the little tiny window, and then the PowerPoint is the full screen.
Yes.
Okay, perfect, perfect. That's exactly what you should see. Thank you for helping. Thank you, thank you, thank you. We will get through this. It's a new year. It's going to be fantastic. We're just going to have this one clunky one. And then after that, it's going to be perfect and beautiful and amazing. We got this. Okay. So now I'm going to go to our first slide. I'm leaving the little thing on the side because I want to be able to, sometimes I can't draw on my screen if very well if it's full screen. So first we get our, get rid of that. Statistics itself, it is a science. It uses the scientific method. If you've taken science classes, you know what scientific method looks like. And so it's very, very similar. There are a lot of different ways. I also teach physics at the high school. So it's like I'm kind of in tune to both of them, both math and physics. And this statistics is actually a really good crossover because it uses the scientific method, just looks slightly different. And the information that we use in statistics is called data or data. I say it both ways, and you're not going to stop me from saying it both ways. Sometimes in the same sentence, I will switch and call it data or data. The weirdest thing is that data are plural. And actually, the word data is a plural word. It's a plural. And I have a really hard time with that. Most of the time, I will not use it as plural. I won't say data are, though that's the proper way to say it, but it just sounds weird to me. So excuse me if I don't say data are, I say the data is, but data is plural. So the data is, it's something that we use. It's information that we use to draw a conclusion or make a decision. Sometimes it's numerical, sometimes it's not numerical. So we're going to take a look at both of those here. So our goal in this class is to be able to prove something is true or not true based on analyzing data. Because there's nothing worse than looking at a study where they've drawn conclusions and you're looking at that going, yeah, there's no way that that is correct. They, just stood outside of Pizza Hut and asked everybody what your favorite pizza place is. It's, this is not a good poll. So you need to be able to look at the way things are questioned and what's going on and say, you know what, there's some errors here. There's some things here that just make it not right. And that's kind of what we're doing in this class. All right. So this slide right here, you will, in your chapter 1 homework, you're going to have to use the information that I have here. I'm going to try to let you know where you're going to see information, and I'll try to let you know something that's going to show up on the test. And I'll also tell you, hey, this is good information, but you're not going to be tested on it. I don't like tricks. I don't know if you've ever had a teacher that tries to trick you or surprise you by having some obscure thing in the book that they never talk about and throw it on the test. I'm not in the business of tricking you. So first, the population. The population is the entire group that you're studying. So you may not pull the entire group, but you're still studying that entire group. So my example here is if we're presenting a study of RCC students to determine there's a correlation between the amount of time studying and the grade they receive, hint, there is, our population is RCC students. So we are studying the entirety of RCC students. So that's our population. So a sample is a subset of the population that's being studied. So generally the sample is the people that you would poll. It would be the people that you talk to, a subset. So it's a smaller piece of that. So in the above study, if I randomly selected 50 RCC students and found out their study hours and their grades, those 50 students, the smaller piece of that population, that would be our sample. And then an individual is just one of those people being studied or objects. So one RCC student would be the individual here. I would talk to each individual in my sample, and then I would take my sample and I would apply what I learned from the sample to the entire population. Any questions so far? We doing okay? All right. Feel free to either unmute and talk to me or type in the chat. Either one is absolutely fine. All right. So when I'm in an in-person class, you walk in the class on the first day and I hand everybody a piece of or a sticky note. So this is what I do when we're in person. So I'm just going to pretend here in this case. So when everybody walks in and I hand them a sticky note, and then I give them this scenario. You're walking down the street, you notice that a person walking in front of you drops $100. No one notices the $100 except you. You could keep the money and nobody's going to know, or you can return the money to the owner. So I ask everybody to anonymously write on their little sticky note whether they would keep the money or return the money. So then I collect them, so it's completely anonymous, and I have some answers. So let's say that even though we have 65 students in our class, yes, that's a lot, but let's pretend I have 30 students and 27 out of those 30 said that they would return the money to the owner. So 27 of them said they would return it. So 27 out of 30, that's 90%. So I'm going to use this draw, and it's going to be really ugly when I draw 90. I can't, oh, that is really, really ugly. I am not good at this. Okay. I wonder, delete. Okay. See? I wonder if I use the touchpad, if it's going to be better. Probably. Nope. Okay, we're just going to draw it. Okay, 90%. There we go. Look how beautiful that 90% is. It's on a surfboard. 90% of our class would return the money to the owner. So this doesn't apply it to anything else. It doesn't say anything about it other than 90% of the people said that they were going to return the money to the owner. So our class is a sample of all of RCC. Since this is a sample, it is considered a statistic. So a statistic is a numerical summary of a sample. So statistic, sample, they both start with S. That's going to help you. That's going to help you to, I see somebody else is sharing. Yeah, okay, there we go. Okay, the statistic and sample. A statistic is a summary of a sample. Statistics refer to samples. I'm going to give you another word that's going to apply to populations pretty soon. So descriptive statistics, it is just a numerical summary that describes whatever the data is. So it could be what we have here. It could be a table. It can be a graph. It's just usually kind of a way of organizing the data, but we haven't done any analysis or anything yet. We're just saying 90% of our class would return the money. So I've described what has happened with my post-it note things. So we're describing the notes without drawing any conclusions. So that's descriptive statistics. So we're still here. Oh, go to the next screen. So we're still at the 90%. Hey, that's a better 90%, a little bit. Okay, so now if I take the results that I got from that sample and I do some math with it, which we are going to learn about in this course, I do some math with it and make it so that I can apply it to the entire population of RCC. And I can start making predictions based on this. This would be inferential statistics. So I'm inferring something based on the sample that I have. When you are taking a sample and you're applying it to the whole population, we need this thing called a margin of error, and we need to have a confidence level. That's going to come later. I'm going to show you how to calculate that later. But you may recall like polls, like election polls and things, it would say 46% of the vote is going to go to this candidate plus or minus 3%. That's basically what we're doing with a margin of error and confidence levels. So I could say, if I'm applying this to all RCC students, I could say that between 87, let's see if I can make this an 8, 87 and 93, oh, I need to make a percent also. I told you this was going to be awkward. It's going to be so much better on Thursday. It'll be 100 times better on Thursday. Thankfully, there's not a lot of math today, so this isn't too bad. Okay, so between 87% and 93% of all RCC students would return the money. So I have put in a margin of error of 3%. We're going to pretend I did all of the math to get that margin of error. I just kind of made it up at this point. We're pretending I did all that math because we haven't learned that math yet. So now I'm making inferences based on my sample. So this would be inferential statistics. We doing okay so far? Y'all hanging in there? Okay. Good. All right. So suppose the percentage of all students on your campus who have a job is 84.9%. This is a parameter because it is a numerical summary of the population. One thing I love about the fact that statistics is referring to a sample, parameters referring to population, they start with the same letter. It's easier to remember. So a sample of 250 students is obtained, and from that sample, we find that 86.4% have a job. This is a statistic because it came from a sample. So this is your gold right here that I'm circling. This is your gold right there. In your chapter 1 homework, you're going to be asked whether something is a statistic or a parameter. So just you're going to need to remember that a statistic is referring to a sample. A parameter is referring to population. So we use inferential statistics to use statistics to estimate parameters, because if you are able to talk to every single person in the population, then we don't actually have to do any of the math because we already have everything. But are you really going to poll every single person in the entire United States? It's not reasonable. I mean, I guess they do it for the census, but otherwise it's just really not reasonable. Right. Questions so far? Are we doing okay? Okay. Make sure you type in the chat or holler at me if I need to slow down or you have questions. All right. I am not going to ask you to give me back the process of statistics. I'm not going to test you on it. I just want you to kind of have an idea of what it looks like. And this kind of shows you our own like scientific method here. So the first thing you want to do when you are using statistics is you need to know your research objective. Before you collect any data, before you do anything with it, you're going to figure out, what question am I trying to answer? What am I looking for? What do I want to know? What is the population I'm going to be studying? Am I studying all RCC students? Am I going to study all drivers in Jackson County? Am I going to be studying, voters in the US? You need to know what it is you're studying and what you want to know about them before you do anything, before you collect any data. So after you know what you want to know, after you know what your objective is, what your question is, then you need to actually collect your data. That is number two. Number two is collecting your data, because now that you have identified your research objective, you're going to know what data you need to collect. So most of the time, you cannot poll an entire population. So what we're going to do is we're going to look at a sample. So you're going to collect it and you're going to make sure that it is collected well. So this little box over here talks about how convenient samples are bad. Convenient sample is like, if I were to, let's, I already kind of mentioned politics. Let's kind of talk about politics. If I was to put a poll on Fox News and say, do you approve of the job the president is doing regarding the economy? You're going to get a very different results from that poll than if you went on MSNBC and put the exact same poll. You're going to get very different results. So those are convenient samples. The internet polls also, another thing about internet surveys, people generally only answer them if they feel strongly one way or another. So if you have a poll on a site, now if somebody looks at it and they don't really care about it very much, they're not going to answer it. But if they feel really strongly, oh, I hate that guy, they're going to make sure they click no. Or, I love him, they're going to make sure to click yes. So people generally don't answer things like that unless they feel strongly one way or another. So you need to try to find a way to do a sample where everybody's going to answer, or people of all walks of life are going to answer. So also phone-in polls, people don't call in. If you put a number on a screen and say, call this to answer these questions, people aren't going to do it unless they feel really strongly about it. So random samples are the best, because you're going to randomly choose from a lot of different people with a lot of different views. So that is the best thing to do, but you just need to be really careful about some of these convenient samples. All right, after you've collected your data, then you're going to you have your descriptive statistics. So just like I did where I said 90% of the class would return the money, I didn't do any kind of analysis with it. All I did was organized what I have. So without doing all of the math with it, number three, you're just organizing the data that you have. And that's kind of what you do. And then you're going to figure out, what kind of statistical methods do I need? What kind of math do I need to do here? Number four is where you're going to actually do your math. You're going to apply your techniques, going to extend the results to the population. If you need to have that margin of error, that's going to happen there. And then I didn't put a number 5, which I should have, but then you're going to write out your conclusion. You're going to say, here's what I concluded. Here's what the data showed me. A lot of times that leads to you repeating it, because I'm sure if you've taken science classes, you know that you need to make sure that your results can be replicated. We kind of do the same thing with statistics. After you get a result, you're like, hey, that was really cool. Now I need to do it again to make sure that I didn't get some sort of an unusual result. So that's the process. That's what we do. And you're not going to go quite as deep into it. We have a big final project at the end, and that is going to lead to you doing something like this. Not quite as deep, but that's weeks away. We don't even have to worry about that. All right. Let's do some examples. Now, I keep saying I'm going to change this example, but here it is. I haven't changed it yet. It is what it is. So we're going to talk about all of the steps with this example. So there was a study out there to evaluate batterer treatment programs. So this was criminal court defendants who were accused of assaulting their intimate female partner. So it was men who battered females, battered women. Okay. So they were comparing non-therapeutic treatments, so like community service, with a batterer treatment program that's probably some sort of a therapeutic program. They took 376 male criminal court defendants. They were accused of assaulting their female partners. They were randomly assigned to either the treatment group, where they were into a 40-hour batterer treatment program, or they did community service, which was 40 hours of community service. After 6 months, it was reported that 21% of the males in the control group had further battering incidents, while 10% of males in the treatment group had further battering incidents. The researchers concluded that the treatment was effective in reducing repeat battering offenses. So they would do this, and then they would likely do it again, do the exact same experiment with a different group to see if they have the same or similar results. So let's take a look at each step. First, identify your research objective. So before they even started gathering their data, before they even chose the men that they were going to put in this program, they wanted to figure out whether males accused of battering their intimate female partners were less likely to batter again if they were in the batterer treatment program than if they had community service. So notice they haven't collected anything yet. They're just thinking, is this better? Will this reduce future battering incidents? Collecting the information. So the way they collected their information is they put them into 2 groups. One of the groups were in the 40-hour batterer treatment program. The second group was in community service. Then after 6 months, they took a look at whether or not each person battered their female partners again. That's the information. Next, describing the data. So they are not actually doing any math with it. All they did was took a look and said, did they or didn't they? And they just marked them down, tally marks or whatever. So the demographic of the characters that were in the experimental control group were similar. After 6 months in the batterer treatment program, 21% of the males in the control group had further battering incidents, while 10%, I had that backwards. The control group was the community service. I am so sorry. 21% of the community service had battering incidents. 10% that were in the treatment group of the batterer treatment program had further incidents. All they did was summarize their information. They haven't done any math yet. Let's do math. They did their math. They extended the results to the entire population to say that the men who are in the batterer treatment program are less likely to batter again. So because this is not numerical, it wasn't like, oh, they had this many incidents. There wasn't a whole lot of math. It was just kind of organizing and analyzing. Obviously, we're going to be doing a lot of math with it because otherwise it wouldn't be a math class, but that's the fun part anyway. So questions on the process of statistics? All right. All right. I'm going to do some more vocabulary here. You will be asked to determine if something is qualitative or qualitative slash categorical or quantitative in your homework. You will be asked that. So having these, and in there's going to be a quiz. The quizzes are super short. They're usually 4 or 5 questions. Most of the time, there's a couple of vocabulary questions there, and they're usually taken pretty much directly from your notes. I highly recommend printing off the PowerPoints, like 2 to a page front and back, so they're not super long, printing them off before class. And then you can just take notes directly on those PowerPoints, and then you can use those notes on your test. So it's super helpful, and it's been pretty successful for a lot of students. So a variable is just a characteristic of an individual. It could be a number, it could be a color, whatever. It's just a characteristic. Variables vary. I know that in regular math classes, variables are always a number. They're not always a number here. So if everybody had the same height or plants grew the same, we wouldn't need variables, and we wouldn't even need statistics because everything would be the same. So qualitative or categorical, those are interchangeable. Think quality, qualitative, or category, categorical. Those are interchangeable. I use both of them interchangeably. I'll go back and forth. I don't remember what my open math uses. That's the our homework program. I don't remember what they use, but we use them interchangeably. So these are things that are usually not numbers, but if they're numbers, then they're numbers that the meaning isn't really numerical. We wouldn't do math with those numbers. So they're based on some attribute or characteristic, like a zip code. A zip code is a number, but it's not a number we do math with. It is more of a characteristic of where you live rather than an actual number. Gender, birth date, it could be quantitative if you're using it like, oh, he was born 3 days after she was born, then that's more quantitative. But if you're just using it as an indicator of somebody was born in the summer because they were born on, June 30th, then that becomes more categorical. And that one is kind of a gray area. I don't usually use it as an example a lot because it's kind of a gray area. But a phone number would be categorical because we don't do numbers with phone numbers. We don't do math with phone numbers. So any number that you're not going to do math with that doesn't have like numerical meaning would be qualitative or categorical. And then anything that's just words. So quantitative, think quantity. Those are numbers you would do math with. Those are numerical measures. They can be added or subtracted. Sometimes they're multiplied or divided. Those would be quantitative. So temperature, number of days someone has studied, height, weight, how much money you have, time spent, reading a book, whatever any numbers that have meaningful numerical meaning that you can do math with, those would be quantitative. Questions? All right. So a couple of examples. Elizabeth Kvavik and some others studied factors that affect eating habits of adults in their mid-30s. And we have some variables classified below. We're going to determine if they are qualitative or quantitative. All right, so nationality. Nationality, I'm going to see if I can write this well and quickly, would be qualitative. Let's see, qualitative, because it is not a number. Haha, okay. I think I'm going to just write C for categorical or Q for quantitative. I don't know. Number of children. So number of children, it is a number that you can do math with. Therefore, even better. Insert. Just put some text boxes here. Okay, number of children it's a number you can do math with. So it'd be quantitative. That was ugly. My U is capital. It's okay. It's quantitative because you can do math with it. Okay, household income in the previous year. Once again, you can do math with household income. So quantitative. Level of education. So with level of education, what we're looking at here is bachelor's degree, master's degree, PhD. It'd be qualitative. I forgot that was there. Daily intake of whole grains. So obviously you're intaking a numerical amount of whole grains. So it's quantitative. I didn't even know that was there. Let me get rid of that. See? How cool is that? All right. Questions on quantitative versus qualitative? I think I have more examples on the next page. Maybe I don't. Nope, I don't. You will, I believe our homework has these questions about quantitative versus qualitative. I believe it does. Okay. Discrete and continuous. You may recall from your algebra class a million years ago, or could be not that long ago, depending on how old you are. Algebra class, we talk about discrete and continuous. They basically have the same meaning here as they do in your regular algebra classes. So a discrete variable, it has a finite number of values, so it can't take on every possible number between two values. So for example, if I asked how many pairs of shoes do you have in your closet, you're not going to say, oh, I've got 8.75 shoes in my closet. No, you're going to have like 6 pair of shoes. You possibly could have 6.5 if you lost a shoe, but in general, it's something that's countable. Discrete is usually countable. If I was to graph discrete on a graph, I would be I would have to lift my pencil in between. Okay, I didn't mean to change the color. So if I was to graph it, it would be dots on a graph. I'd have to lift my pencil in between the dots because I can't have number of students in the class. I don't have 38.3 students in the class. I'd have 38 or 39 or 40. It's something countable. How many TVs were sold last week? Something countable. Number of red marbles in a jar. So it's something that you can count. Now, continuous variables, on the other hand, can take on any value in between. So if I was to graph it, I don't have to lift my pencil. Okay, so it's a height of a student's in class. So in order for me, I am a very short person. I'm 5'2", but in order to get up to 5.2, I had to at some point be 5 foot. And then I was 5 foot and half an inch. Then I was 5'1". I had to hit every single value in between. So it can take on every value in between. Time it takes to get to school. It takes me 30 minutes to drive to the high school I work at out in Cave Junction. It takes me 30 minutes to get there. I have to drive 29 and a half minutes before I drive 30 minutes. It can take on every value in between. Weight of a baby. Babies have to grow. They grow from the tiny little embryo, and then they get bigger and bigger and bigger, and they take on every weight up until they get to their birth weight. They don't just out of thin air hit 7 pounds 3 ounces. They had to hit every one in between. So it was continuous. It was a growth. Usually there's some sort of growth. Rainfall. You have to get 3.5 inches of rain before you can get 4 inches of rain. I hope that makes sense. And you will be on the homework. You will be asked continuous and discrete. And I think there's a question on the quiz about continuous and discrete. So looking down here at my little graphic down at the bottom, discrete and continuous apply only to quantitative variables. It doesn't even make sense with qualitative or categorical. It doesn't even make sense. So it only applies to quantitative. All right. So let's look at some examples. I want to quit the draw thing. How do I get out of that? Okay, I don't know. All right. I don't know. Okay. So number of children somebody has. So this is still Elizabeth Kavavic. We're looking at things. So we want to know if number of children is continuous or discrete. It's countable, something countable. So it is. Oh, wait, look. I don't have to type it. It is discrete. Because it is countable, you're not going to have 3.5 children. Household income for this previous year. Even though you can get it down to pennies and pennies are countable, something like income is we always consider it continuous, because I can't make $15,000 unless I made $14,999 a year. Yes, technically it gets rounded to the nearest, 15 minutes or whatever on the time clock, but we consider something like income, we keep that as continuous. Let's see if I have that to remove. I do. Daily intake of whole grains. Now, I guess if you were splitting hairs and you were being really picky about it, I guess technically you could make it discrete, but once again, it's such a small amount, and we generally don't eat just 1 gram at a time. You're usually taking bites, eating bowlfuls, whatever. So therefore, it's continuous. Questions? All right. So before I give you the next, we work on the next section, I want to give you a heads up that the levels of measurement is something that has caused people to be really confused in the past. They struggle with it. So I'm going to give you the things that I use to remember them, the things that I use to look for them. And if you take the notes directly on the PowerPoint, or at least you write down, hey, look for this, it should work for you, and it should help you. And I think I'm going to insert words in here to kind of help out. Let me see here. It would help if I could write on it, but that's okay. You know what? I'm going to do the best I can. Maybe I'll make this font a little bit smaller, and I'm going to color it so that you can see it. Let's do purple, because purple is pretty. Okay. So the first two levels of measurement are for categorical or qualitative. Categorical. So the first two are categorical. I'm going to change the color again because I messed it up last time. All right. So this one and the one next to it, both of those are categorical. So there's a difference here with nominal and ordinal. So with nominal, it's going to be a category. It's going to have, it's going to be a word or a number that you don't do math with. So a non-mathematically significant number. And the order's not going to matter. So we don't have to list gender in a specific order. You don't have to list right and left-handedness in a specific order. If you were doing a poll of what religion different people followed, order wouldn't matter. You're not going to be like, okay, well, the top is going to be this religion, and then the second one has to be this one because that's the order we write them in. Or favorite colors. It does not matter what's listed first and second and third. It doesn't matter. Order doesn't matter. So therefore, it is the nominal level. So I'm going to write order doesn't matter because that's what I look for. So order doesn't matter. Make that longer. So for nominal, order doesn't matter, and it is categorical. Okay, for ordinal level of measurement. So ordinal is very similar to nominal. It's going to be a categorical variable. And so it's not going to be a number unless it's not a number you would do math with. So it's still categorical, but the difference here is that order does matter. It's something that you list the order in a specific way. So I'm going to put this down here, and I'm going to get rid of the doesn't. So order does matter. Uh-oh. Hate when that happens. So here, order does matter. So for example, you see satisfaction ratings, you know, when you take a poll and satisfaction ratings. And so all the way on the left, you'd have extremely dissatisfied, then you'd have dissatisfied, then you'd have neutral, and then you'd have satisfied, and then you'd have extremely satisfied. Order matters there. Grades, A, B, C, D, F, order matters. So things that order matters, or if you're looking at levels of education, you get an associate's degree, then you could have a bachelor's, then a master's, then a PhD. Order matters. So the ordinal level of measurement is when order matters, but it is still categorical. Next, the next two are both quantitative. So let's put this down here. I'm probably making this much more difficult than it needs to be, but that is kind of my MO. It's what I do. I make things difficult. Okay, these are going to be quantitative. These are quantitative, both of these are. Both the interval and the ratio level. So their difference is going to be about 0. So it's going to be, these are going to be quantitative. They're going to be numbers. They're going to be numbers you can do math with, but they're going to be specific numbers you can do math with. So important thing here, and I'm going to do this, a value of 0, whoa, let's fix that line. A value of 0 does not mean absence of quantity. This is super important. This is one of the things I look for. A value of 0 doesn't mean absence of quantity. When I'm looking at a quantitative value and trying to determine the level of measurement, which one of these it is, I first say to myself, does the value of 0 mean an absence of quantity? And then answer yes or no on that. So for example, a temperature of 0 doesn't mean that there's no temperature. It just means it's very cold. A calendar year of 0, which really doesn't exist, but a calendar year of 0 doesn't mean that there's no years. It doesn't mean that there's no time. An elevation of 0 does not mean that there's no elevation. So value of 0 doesn't make any sense in some of these. That would be interval if the value of 0 doesn't mean absence of quantity. Additionally, the math you do with it is generally addition and subtraction. I'm not going to say it's twice as hot as today as it was yesterday. That's just weird. I would say it's 5 degrees hotter today than it was yesterday. Calendar years, he was born 3 times as many years later than, I don't even know how to even say that. You can say he was born 20 years ago. Elevation, this mountain's twice as high as that one. I mean, you might say that, but normally you'd be like, you know, this mountain is 1,500 feet higher than the other mountain. So the math you do with that would generally be addition and subtraction. It makes the most sense. So for ratio level of measurement, all the things that were wrong with the first one are right with this one. Once again, it is quantitative. Here we have a value of 0 means absence of quantity. I have $0 in my pocket. That means there's no money in my pocket. If something is 0 feet tall, then it doesn't exist. It's an absence of quantity there. It doesn't exist. I spent 0 hours watching TV today. That means I didn't watch TV today. You see what I mean there? Now, you can do math, multiplication, and division with this. The ratio you can do multiplication and division with. I watched 3 times as much TV on Sunday than I did today. I can say I watched, you know, I studied twice as long this week than I did last week. I have 5 times as much money as my grandson does in his pocket. He could have a dime, and then I have 50 cents. So you can do multiplication and division with this math. Yes, you also can do addition and subtraction, but you can do multiplication and division here. The zero thing is usually what helps me the most, but those are the ways to test it. Any questions on these before we do look at a couple examples? Okay. All right. These weren't already supposed to be here. Oh, well. So gender is nominal because gender does not have order. Temperature is interval because the zero does not mean absence of value. Number of days a college student studied this week. 0 means they did not study at all. So it's ratio. Letter grade earned in stats class, once again, A, B, C, D, F, but nobody in here is going to get a D or an F, so we're not even going to worry about those. But A, B, C, D, F, it's ordinal. Order matters. All right, this is the end of the chapter 1. We are going to spend a little bit of time in chapter 2. This is the end of chapter 1. You have enough information to do your chapter 1 homework, just FYI. So if you keep track of that sort of thing, we're done with chapter 1. See, there was no math, all vocabulary. Number 2, chapter 2, it's not super mathy, but we're going to have some graphs. We're not going fully into chapter 2. Yes, we still have, how many more slides? We still have like 15 more slides, but a lot of them are super fast. So we're almost there. This is why I said I won't talk for 2.5 hours. Nobody wants to hear me talk for 2.5 hours. I will never, ever do that to you. I think one of our classes we go to about 7, but I don't think any of them go after 7 unless there's a lot of questions. So most of the time we're done by about 6:30. Okay, so I want you to remember that qualitative or categorical data is things like words or numbers that don't matter. They matter, but that we don't do math with. So a frequency distribution. So this is a really fancy way that we say that we would list every category of data, and then we're going to write how often that item comes up, how frequently it shows up. So basically, if I was walking through a parking lot and I was looking at the colors of cars in the parking lot, I would list all of the colors that show up. And then I'd probably do like tick marks to say how many times I saw each color of car, so that how many times would be the frequency it showed up. So that's what a frequency distribution does. All right. So raw data is data that hasn't been cooked yet. That's how I think of it. So if I was still walking through the parking lot, and I'm looking at the cars in the parking lot and writing down their colors, I would just write down the colors as I see them. I would just write down white, gray, red, blue, brown. I'm just writing them down. So it's just a big pile of data that has not been organized. So it's called raw data if it is just basically as I collected it, I wrote it down. It's just raw. I haven't done anything with it yet. I have not organized it. I haven't crunched any numbers. It's just raw data. So we can use tables, graphs, or numerical summaries to organize our data. And we're going to do a little bit of that here today. So here we go. So the next slide is going to have a bunch of M&Ms that as I pulled them out of the bag, I just wrote them down. So this right here is raw data, and it is just a big pile of data. As I pulled them out of the bag, I typed out what color it was. That was it. So it's just raw, has not been cooked. The next slide, I'm going to organize it. So here we go. This is my frequency table. When you make a frequency table, you don't have to necessarily show the tally marks. If you just put the category on the left and then list out the number of times it showed up on the right, this was my frequency table. So yellow shows up 10 times. So the frequency of yellow is 10. Just shows up 10 times. It's as simple as that. This is our frequency table. Super helpful if I want to kind of see, am I likely to pull out a blue one if I just randomly chose one? Probably not, because only 3 of them are blue. All right. So relative frequency, it helps us when, if I had 2 different bags of M&Ms and there were a different number of M&Ms in each bag, I would want to know what proportion of M&Ms, it's like maybe one of them had 45 in it, and the other one had 38 in it. If I want to know the one with 45 might say, well, you know what? I had 8 brown M&Ms in my bag. And the other person could say, I had only 7 browns in mine. I'm being shortchanged. But we're not comparing apples to apples because one bag has more than the other. So it's helpful to know the proportion of brown M&Ms that were in each bag. So what we do is we take the frequency. So you would take that 8 brown M&Ms that I have and then put the total number of M&Ms on the bottom. So it'd be 45. So I'd know 8 out of 45 were brown. If I have that relative frequency, I can compare apples to apples. I could see what is the proportion of brown M&Ms that are in both bags. So we frequently use relative frequency to compare things. A relative frequency distribution looks a lot like a regular frequency distribution. We just have the relative frequency there. So let me show you that on the next page. So here it is. So what I did is I knew I had 45 M&Ms in the bag. So I did 12 divided by 45, and I could see that the proportion of brown M&Ms I have in the bag is 0.2667, or about 27% of the bag is brown M&Ms. So did the same thing with yellow. I did 10 divided by 45, and I got 0.222, and onward and onward. So you can see that blue M&Ms are just about 7%. Because in your previous math classes, I'm sure you converted decimals to percent. You just move that decimal place over 2. So my decimal would be here instead. That was really ugly. I'm just going to erase that. So all you're doing is just moving that decimal place over to make it a percent. Now, me personally, I don't care if you write it as a percent or just a regular decimal. My open math's picky, so pay attention to how they're asking for it. But if you're taking my test or doing the hand and homework, I don't care how you do it, but just pay attention to what my open math wants. Questions so far? All right, we're close. All right, so we're going to talk about bar graphs. So when you've seen a million bar graphs in your life, I know that we've all seen a million of them. We're pretty specific about what we're looking for in a bar graph. A couple of things I'm going to point out that you must include. So on a bar graph, we label every category of data, and you're going to label your horizontal and your vertical axis. So the vertical axis, which is normally the y-axis, we'll put either frequency or relative frequency, depending on what we're using. And then the horizontal axis, which would usually be the x-axis, that's going to be where your categories are. So as far as M&Ms go, that would be your colors. Our rectangles are equal width. They don't touch each other, but the height of the rectangle represents the frequency or the relative frequency. I'm going to show you an M&M graph. Okay, where am I? That's where I just was. Okay, so I'm going to use the M&Ms and I'm going to make a graph. I have a weird extra thing in there. So here's the frequency table, and here is my graph. Important things to remember. Your bar graph must always have a title. When you create a bar graph, you need to have a title up here. It doesn't need to be super fancy. Oh, that was fun. It doesn't need to be super fancy. I don't care if it's a fancy title. Just give me a title that explains what's in there. Okay. You need to label your horizontal axis. Oh, that's ugly too. Label the horizontal axis. Here, I just labeled it color. So I know it's M&Ms because my title says that. But label that. And then you have your categories labeled. Label your vertical axis. In this case, it's frequency. Most of the time, it's either frequency or relative frequency. So for bar graphs, you're going to have either relative frequency or frequency, depending on what you have. So on this bar graph, you can see that, for example, on orange M&Ms, the bar goes up to the 6 of the frequency. This indicates we have 6 orange M&Ms. And I know you've read bar graphs before, just making sure I cover all the bases. So this is just our regular frequency bar graph. Let's do a relative frequency. So once again, this is my relative frequency table. The relative frequency bar graph looks almost identical to the other one. It's almost identical. The difference is we have our relative frequency along the side instead. Our bars still go up, but now it goes up to whatever that relative frequency is. You can see on the red, 20% or 0.2 of our M&Ms were red. You can see that bar goes up to 0.2. Still, we have a title on our graph, title on the x-axis, title on the y-axis. Make sure those are there. All right, we only have 2 more slides. We've got this. So you will never, ever, ever be asked about the next graph, but it is part of our standards, so I'm going to tell you about it. A Pareto chart just makes it pretty. So the bars are drawn in a decreasing order of frequency. So here, notice how on the last one, it goes down, 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 and then blue is the shortest, and then it goes back up to green. On the Pareto chart, it's from the highest to the lowest. Well, I don't know where blue went. Blue just disappeared, but pretend it's there. It just goes from the highest to the lowest on a Pareto chart. It's just organizing it to make it look pretty. And there are a lot of things that we want to make look pretty in stats, and statisticians frequently are trying to make things look pretty. So that's what it's there for. It makes things pretty. So before we move on to the next, sorry, I just lost my train of thought. So are there any questions on the slides before I talk about what to expect next Thursday? On Thursday, okay. So on Thursday, we're going to have our first lab. So if you want to, I'm going to actually walk you through it, and we will be happily using my MacBook next Thursday, and it'll all be pretty, and it'll be easier, and we'll be able to record the screen and share and do everything. We'll be able to do all of that on Thursday. So before we get there, we're going to need some data for lab 1. I believe lab 1's happening. Let me go to my other screen and make sure that lab 1 is this week. I think it is. I'm pretty sure. Let's go into this. Come on, open, open, open. Are you opening? No. How come it's not opening? There it is. We do have lab 1. Okay, good. So go back to my Zoom meeting. That's not my Zoom meeting. Okay. I don't know why things are being weird. Okay. Anyway, so, oh, I know what it is. I want this up. You're going to need 3 types of data. So you're going to need 20 data values. Let's see if I can, I'm just going to type it out because it makes it prettier. I'm going to insert another slide, insert a new slide, and I'm going to type it out. Why not? Okay. Come on, insert text box. All right. So now for the first, you're going to need 20 categorical data values. So some examples of categorical data could just be colors of books on your bookshelf, colors of cars passing by your house, genre of songs on your playlist. Maybe you have, like, country, rap, alternative, whatever. It could be anything. Just choose 20 things and don't overthink it. Now is not the time to get super creative and overthink it. Now, if you want to, you're more than welcome to. Um, maybe you're going to take a random deck of Pokemon cards, look at 20 cards and say what type of Pokemon they are. Hey, that would be fun. Nobody's ever done that before. If you have Pokemon cards, someone should do that. That's really cool. Anyway, just categorical, super simple. I just choose 20 categorical data values. You also will need 20 continuous data values. So continuous, it could be, maybe you like vinyl. Maybe you take, or even your Spotify playlist, 20 songs. How long are they? The height of 20 of your friends. Now, if you do that, either convert it all the way to feet or all the way to inches. Do not keep it feet and inches. So 5'6" would be 5.5 feet, or be 65 inches. So convert it one way or the other. So see, height of 20 friends. It could be rainfall totals last 20 days. And pick your city. It could be maybe you can look on your power bill and you can look at power used last 20 days. Just pick something, make it simple. I'm not looking for complicated here, but I'm going to tell you, we are going to use the continuous data in 2 future labs. So if you put any real thought into any of it, continuous is probably where you're going to want to put your thought, but still not super important. Okay. So last, you need 20 discrete data values. Remember, discrete is still quantitative, but it is numbers that we don't do math with, or numbers that can't take on every value. So countable things. So number of kids of 20 friends, number of songs in 20 playlists, number of chapters in 20 books. So anything like that. So it's something that's countable. That's it. And I know that seems like a lot, and this is the lab that is worth the most points. It's terrible that it happens the first week, but it is what it is. And it's actually kind of fun, and it shouldn't take too long. It's actually kind of a fun lab. So hopefully you enjoy it. I'm going to go over it in detail on Thursday. I will walk you through it. So if you already have your data, you can do it right after I teach it. You don't necessarily have to have it on Thursday, but it could be helpful if you want to work on it right away after class. Questions about the lab? I mean, obviously, you don't know how to do it yet, but questions about the data that you need. Or maybe you have an idea of, and you want to know if it fits in one of those places. All right, so I don't have anything else tonight. Any questions that are not about tonight's lesson that you want? Remember, it's being recorded, so that you want on the recording. Any questions you have for on the recording? Go ahead, Ellie.
So I just got here.
Okay, I can't hear you. Okay, I hear you now.
Oh, you hear me?
I can kind of hear you. Go ahead.
Yeah, is this better?
Yes, perfect.
Okay. So I like just got here like at like 6:30
Okay,
because I had something going on.
no
Um,
problem.
so like how much did I miss? Like,
Well, you missed quite a bit, but it's okay. This is being recorded. And if you don't like this recording because there were plenty of technical issues, there's also the video in the week's materials that you can look at. It covers the same thing.
Okay.
So yeah,
Okay,
so you
thank
should
you.
be, yes, you're welcome. So Kyla asks what I said about printing out the slides to take notes on. So the slideshows are located in the week's materials. So if you would have clicked on the chapter 1 section, I'll go back there. So if I was to click on chapter 1, right here, it says PowerPoint to be used with video. If you click on that, it's the same PowerPoint I use in class. And then we can go back and go to chapter 2, and there's PowerPoints for 2.1, and there's a PowerPoint for 2.2. You can print them out. You can print at the college for free, or if you want to print on your own. If you print them 2 per page and then front and back, it's not an overwhelming amount of paper and there's plenty of room to write on them. You can take your notes directly on the slides that I use in class, and then you can use those notes for your test.
Thank you. If we choose to just take notes in a notebook, are we able to bring those notes for the
Yes,
test?
yes, you
Okay,
absolutely can. I just know a lot of people have found it super helpful to take notes on the slides, so that's why I recommend that.
that is a lovely idea. Thank you.
You're welcome. Anyone else while we're still recording? Okay, now I'm going to figure out how to quit the recording because I can't find my bar. Let me see here. Okay. It's not allowing. I don't know where my bar is. Okay, let's see. Yeah, I don't know. I don't know where it went. But okay, wait, here we go. Okay, I'm going to stop the recording now. Okay, wait. Uh-oh. There we go. I'm going to stop the recording and